Hey guys, welcome to day 36 of Codeforces Every Day until GM. Today we're going to start with C secret message, the contest question that we were not able to do yesterday. Now, I've tried getting some advice from friends on this question and it's been kind of a mixed bag. I think my solution is pretty close, it works. Yes, it's brute force, but um I think with a few micro optimizations, we could be able to figure out a solution. Um, it works. It's just TLEing, right? Like if we micro optimize a little bit, we might be able to get this to pass. Um, Otherwise, we just have to do a totally new approach or something. So I do have a few ideas in mind. And the main bottleneck is just this part, right? We kind of want to try to clean up one of these for loops, and we can probably get rid of like this grouping here with what's it called? Like list frick, I forgot what it's called. List operations or whatever it's called. But okay, so we're getting the group and we're shoving all the groups in here. What we can probably do is call let me think. Call J N P. Yeah, same as this. And okay, this is very bad because it's Python. Uh so I low key, I think if I wrote a C++ version of this code, it would just pass. But okay, but I'm pretty sure I was doing some research and I'm pretty sure this is technically faster than what we were doing before because Python does this in C or uh yeah, and it's just faster than for looping in Python. So I think we can just get rid of all of this. And since we have no I anymore, we can replace J with I. And then what can we do? We can compute periods with. Let's check if it still works. It fails. Okay. Y. Let's just. Okay, this works. Why doesn't this work? Exactly. Oh, let's replace this with I. Set object not subscriptable. What does that mean? Let me Google this. Oh, because call is a set. Okay, so we can probably rework this part. Oh, it's calls. Right, okay. Okay, yeah. That makes sense. Now the next thing I want to do is we can find divisors in like square root of n time because the idea, let me pull up Scala draw. The idea, I don't know if I went over this last time, but the idea is that like once you, so let's just do something like 8, square root of 8 plus 1, or like you seal it, is roughly QRT 8 is 2. So sealed to 3. We basically only have to check up to let me think. Let's pick a better number. Let me see if I remember the implementation first. It's like for I in range 1, and then it's it's in 0.5, and then you make this an int plus 1. Let me think. And then okay, yeah, the idea is some okay, so for every divisor you check, you're technically checking for two divisors, right? So let's take like 36. We have 1 and 36. And then we have 2 and 18, 3, 12, 4, 9, and then 6, 6. And then after 6, the next number would be 9. But then we repeat, right? We repeat this one, and then we repeat this one. So that's why you only need to really check up to the square root, because you're checking two numbers at a time. So this should, instead of being O of n check, it should be square root of n check. So what we can do is check this periods.append, and then if I does not equal to n divided by I, result periods dot append n divided by I. So we append I, and then we append n divided by I. And then I guess we would have to sort them, right? Do we have to sort them, or can we just try all of them? Minimal. So we do have to sort them. Which I don't like that about this one. The other one auto sorts it. Sorting time complexity is n log n, right? Okay. But the other one was O of n, so is that even faster? Hmm. I guess we're only sorting the number of divisors. So this is square root of n, and then worst case, every number is a divisor, but that's with like 8. That's not even, let's be like 2. So it's basically negligible. So what we can do is periods.sort okay. Now we have square root of n what's the next thing we can do? The next thing that was recommended was that string concatenation versus list plus join. So this happens Let me think. So the idea was that what we're basically doing is we're creating. Okay, strings are immutable in Python, so every time you add to a string, you're basically creating a new string of length string plus 1, copying the string, copying the character you want to add, and then throwing the new string, which is basically if you have a string length n, it's like O to the n squared when you have it inside of a loop. So this is actually quadratic. So what we can try is to print is this, and then we to append next iter common let me think. Yeah, that should be right. And then I don't know why we did this. We're gonna do if flag print in break, but since print is a list now, we can just do dot join to print times p. N divided by p. Okay. So we like technically micro optimized a little bit. Is this fast enough? Oh, yeah, it is. So I don't really know where the bottleneck was, but we made this faster. We made this faster. We made this faster. I guess it was bits and pieces of each. It's like slightly faster. Um, like we're within the constraints by what is it? 2 seconds. So by 47 milliseconds, we are within the constraints. Interesting. Let me take a look at something. So what we can do is we can actually go to, I think it's here. Okay. Let's look at these guys' time. Python. This guy submitted 5 times for some reason. He's getting times under. Like way lower. This guy's Python, 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 Python. This guy got around me. Whoa. In Python? Oh yeah, I have no idea what this guy's doing. This doesn't even look like Python anymore. this, this guy's coding like he's using C++. Or he's tracking. Okay, this was another thing recommended to me, is instead of using a set, you can track an array of length 26 for all the characters. Then you would do ord minus 97, but I didn't think I needed that much. Okay, but apparently that is very fast, so then some of these other ones, let's take a look at this. This guy hates using new lines. .zip. I don't even know what .zip does. Star map. Okay. Yeah, whatever. My code works. So, fuck off. Alright. Let's pull up the A2OJ ladder and we'll just do a few questions. Z3742. Why is it prompting for my username again? Change user. KazZ3742. Oh, here's another thing that I wanted to point out. We were able to do 2 questions yesterday, right? Let me kill my email so I can show this. We were able to do 2 questions yesterday, which just about bumped us over 1000 contest rating. We only gained 47 points, which is lame, but we're over 1000 now. We are plateauing quite a bit. So I guess I need to do some serious learning. I will say question A took a lot longer than it should have. And question B was reasonable, I would say. Lawnmower. Yeah, lawnmower, like we solved this really quickly actually. The problem was like there was this one edge case if you look at the solutions that I wasn't really sure how to handle, is this one here. I thought like this would just be invalid and we'd call it a day. But it ends up just, you can just print in. So that was why that one took so long. The other one actually required some thinking. I liked that question a lot. So that one took time, which is fine. But that means we didn't have time for this question. And obviously, like, I mean, I was able to come up with a solution. It's just too slow. And then finding how to optimize it would have, yeah, this probably would have taken my entire time if I just started with this question. So anyway, next time we do a Div 2, let's try to do 3. And then hopefully we'll gain even more points. Let's try by like the 3rd month. Let's pass 1200. Yeah, that's a good goal. Keeping the everyday streak. All right, let's do some questions. We got to do at least 2s to get that dark green. Move this over here. Yeah. Okay. 1200, it's a math problem. Okay. Lahab and Lahabina went on a date, luxury restaurant, everything was fine until paying for food. Writes a hungry sentence consisting of in-its. A sequence is hungry if and only if the elements are in increasing order, so it's sorted. And an inequality AI AJ holds true for any two. Yeah, I know what a sorted list is. For any two indices must not be able to be divisible by AI. What does that mean? So if I have, I'll figure it out later. In trouble, he wants help find a hungry sequence with in elements. Input is in. And then we want to output a hungry sequence. So basically the idea of this problem is to find a formula and then iterate through the formula and pump out numbers, right? So for the most confusing part of this is this line here. This line is just saying it has to be sorted, increasing order. Any two indices I and j, aj must not be divisible by ai. So 9 is not divisible by 2, 15 is not divisible by 2. Okay. So what we can do, I think, is just to pump out prime numbers. We just pump out the first in primes. That would work, no? Am I missing something? Or what was the one thing that my buddy recommended this to me before? I asked him about like what was the best way to go about finding primes. Sieve of Eratosthenes. Or you can just square root brute force. Let's Google sieve of Eratosthenes. Finding all prime numbers up to a specified integer n by iteratively marking multiples of prime. Okay. Now we just have to implement. Alright, so what does sieve of Eratosthenes actually do? It generates all prime numbers up to and including n. We just want the first n prime numbers. Let me think, how could we start this? The issue right now is like we can basically just implement the sieve for n, but that will find all primes up to n. This is an issue because that's like you're doing so much extra computation. But now we only want to generate the first n primes, which means we don't actually know how large our search range needs to be. Prime number theorem. So for large enough n, the probability that a random integer not greater than n is prime is very close to 1 divided by log n. So in other words, prime number theorem suggests that the nth prime is roughly n log or n ln n, and we can use an upper bound to make sure. So okay, let's try. I have low-key no idea what I'm doing for this problem because I just googled a ton of shit that makes sense. Let's bookmark this question. So we have to implement a sieve. We have to implement an algo with that finds largest bound with this, and or estimates largest bound, and then we have to implement a sieve of Eratosthenes. Right. What's it? Okay. So what we can do is what are the bounds for this question? N can be 1, so if n is equal to 1, turn, just print. To exit. I guess we don't even need to manage this case actually. Okay, so our upper bound would be equal to int n log n uh, n hmm. Okay, there's also this guy's theorem, Rosser's theorem. Let's Google this real quick. Why am I learning math? Rosser's theorem. Prime number theorem shows that the nth prime number Pn has an asymptotic value. Pn is roughly n log n. Okay. Makes this a rigorous lower bound by stating Pn. The result was improved to this, where C is 3 divided by 2. Constant C, okay. C1 was admissible for. Okay, what's our highest bound is 10 to the 5, which is below this, right? So we can use a C of 1. So, okay, this formula. We are basically copying this formula, not just n log n, right? So it's n times math log n plus it's this inside of itself. And then minus 1. Okay. Now we implement the sieve. Primes. Is prime equals. Bro, I need to read about this more. Creates a Boolean array. True. Size n plus 1. I can do that. Initialize, it starts at first prime number 2, marks all multiples as false, moves, okay. Creates a list of consecutive integers. First number greater than P that's not marked. Oh, they have a implementation which we will not look at because we will try to figure it out ourselves. Okay. Check each. So we have the first part, and then we start at 2, right? For P in range 2 in our upper bound here. Uh, then check if is prime P, so the current one is prime dot append P. If len prime is equal to n, then we break. For I in range to mark okay, starting from P times P, since smaller multiples have already been marked by smaller primes. Okay. Our limit. Dude, imagine there's just like a very easy answer to this, like something to do with even, like some, not just primes, because they're using evens in here. Now that I think about it, could you not just like pick 3 and then you can pick any prime number and then any multiple? Like we could do 3. No, that doesn't work. 6, 9. Yeah, that doesn't. Never mind. Okay. Then for iron range P times P, our upper bound our upper bound. And then we increment it's by p. Then is prime I equals false, right? And then at the end we can print primes star. So if I do 3, it's over. I fucked something up. What's wrong with this? What's our upper bound? 3. Our upper bound is... Okay, let's do something like... 15. Index out of range. Wait, figure out if this is working. 40. Our upper bound is 40. List of all primes. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's not good. The answer is greater than whatever the fuck we have over here. Okay, let's get rid of this -1. 55. I don't know why that worked, but... Okay, so we just got rid of the C value. Is that significant? And we're still out of range. Prime is prime true for primes dot append, so it's... We're fucking up here somehow. P in range. Is prime I equals false is giving an index out of range. Okay, what is... Can I... 2? Wait. Per bound. Our upper bound is 3. So it's 2, 3. I don't... Why is there so many of them? True times 3 plus 1. Ah. I see. 3 plus 1 is 4. Wait, there shouldn't be in, right? There should be upper bound. Do these need to be? Because if we start at 2. Wait. Huh? Upper bound is 3. Oh. Let's delete this. I kind of want to print is prime. Two. I don't really understand how this thing works. Why isn't it supposed to be setting it to false? Oh. There we go. Okay, because this is 0 and 1, and we just ignore these. Start at 2, 3. So we're only looking at these two here. 2, 3. False 4, or this 2, 3, 4, 5, 6. Wait. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's really cool. Okay. I'm gonna have to review this question because this was a lot of Googling. This was the first question where I had to like significantly deal with primes. Now wait till I just misread the whole problem and wait for there to be like a way easier solution to this. But I kind of want to see the attendance. Oh, it's cooked. They just wasted a ton of time for no reason. Wrong answer. Nah, 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 nah. The first number is not smaller. The first number is not smaller. Oh, I only have 2 numbers here. I need 3 numbers. Right, so okay. Huh. The first number is not smaller than the second number. What does that mean? Did I totally misread the question? I just about dropped half an hour on this question, no? Okay, let's reread. Where is the question? Okay. Any two indices must not. Oh, indices. AI. I and J. AJ must not be divisible by AI. Wait, yeah? For any AJ, 3 is not divisible by 2, 5 is not divisible by 2. Oh, wait, is it because. Oh. Putting upper bound. Okay, I passed test 1. What the heck? Wrong output format. Extra information in the output file? 5. Why am I printing out 6 numbers here? Random primes. Let's print the upper bound. Upper bound is 3. What is wrong with my code? Hmm. Why is it 3? What's the smallest possible in 1? 1 throws an error. Two is 0. Our upper bound is 0. That's not good. 3, our upper bound is 3. 4, our upper bound is 6. That's still not 4 numbers. 5, our upper bound is 10. It's not 5 numbers. 6, our upper bound. Okay, so until 6, we just don't find enough primes. So 3. Okay, this could be a pretty hacky solution, but 3, 6, 6. If it's 2, then we would have 5. 2 would be 2, 3, enough. 3, 6. If it was 2, it would be 5. Okay, we could just add 3 to this. Be 6 would be at 9. For our upper bound. Okay, 1 still needs a special case, but 3 should handle all these correctly now. 5, 6. Yeah. If n equals 1, print 2, exit. Okay, let's try. It's Jover, it's Sojo. I'm still printing this upper bound. Gosh, I gotta remove my debug statements. We got it. Wow, this question was such a struggle. I submitted 5 times. What is the actual solution to this? Each hungry number from isn't allowed to be divided by any number smaller than it. each number one in itself. So primes, right? Yeah. Brute force or seriousness. Okay, so they're saying this shit was not even required to solve. We could just brute force it. It's Jover. Oh, it makes such a complicated solution. Array is always hungry. Oh, wait, this is pretty cool. Whatever. The video's already an hour long. We'll just end it here. I'll do one more question on my own, just so I can process this video before midnight. Also have some homework to do, so yeah. If y'all enjoyed this struggle fest of a video, be sure to like and subscribe. I'll see y'all guys tomorrow. Bye.